Hey guys, welcome to my channel. Today we are going to study what is analysis of algorithm. These topics we are going to cover in this presentation, they are what is an algorithm, why we should analyze the algorithm, asymptotic notations and analysis of it, big O notation and types of analysis and common algorithms, space complexity, trade-offs, real-world applications, and we are going to conclude this presentation. So, coming on to introduction. Welcome to the world of algorithm analysis. So, in today's fast paced technological landscapes, algorithms are everywhere. From the apps on your phone to the software car that runs. But have you ever noticed or stopped to think about the algorithms which work behind? That's where algorithm analysis comes in. It is the process of studying and understanding how algorithm performs, and it's essential part of computer science. By analyzing algorithms, we can optimize their performance, improve efficiency and solve the complex problems in a faster manner. So let's get started and let us know what is algorithm. So algorithm is a set of instructions that a computer follows to break down a complete task into a simpler ones and make it understand. These instructions can be simply as adding two numbers together and are or as complex as sorting a large set of data. Algorithms are essential to computer science and used in wide variety of applications. One example of algorithm is a binary search algorithm. This algorithm is used to search for a specific value in a sorted list. By repeatedly dividing the last list in half, the algorithm quickly narrows down the possible location of the value until it is found. Another example of algorithm is bubble sorting algorithm. In this algorithm, there is a list which is being repeatedly swapped by adjacent elements until the list gets sorted. Why we should analyze the algorithm? So analyzing an algorithm is a crucial step in computer science because it allows us to understand how efficiently a program will run. By analyzing the time complexity of an algorithm, we can determine how long it takes to execute different input sizes. The information is crucial when the design software that needs to handle a large amounts of data or run in real time. Another benefits of analyzing an algorithm is that it helps us to identify the area where we can optimize our code. By understanding which part of a program are taking the most time, we can focus on improving those areas and make our software more efficient overall. This can lead to significant performance improvements and cost saving in industries such as finance, where even small gains in speed can translate into millions of dollars in profit. So, what is asymptotic analysis? So, analysis is a mathematical method used to describe the, the performance of an algorithm as the input size approaches into infinity. It allows us to compare algorithm and determine which one is more efficient in terms of space complexity. For example, let's say we have two algorithms that sort a number of lists. Algorithm A takes n to the power 2 times to complete, while algorithm B takes n log n times. So asymptotic analysis tells us that as the input size of gets larger, the algorithm B will eventually be faster than eventually an algorithm A. Big O notation. Big O notation is a mathematical notation that describes the limiting behavior of a function when the argument tends towards a particular value or infinity. In an algorithm analysis, it is used to describe the time complexity of an algorithm, which is the amount of time it takes for an algorithm to complete as a function of its input size. For example, if we have an algorithm that takes n to the power 2 times to complete, we could say that the time complexity is O in brackets n to the power 2. This means that the size of inputs grow, the time it takes for an algorithm to complete will also grow at the same rate. Other common notations include O1 or static 1 for constant time algorithms and O log n times for logarithmic time algorithms. Types of analysis. There are three types of algorithm analysis: worst case, best case, and average case analysis. Worst case analysis involves finding the maximum amount of time an algorithm could take to complete. Best case analysis involves finding the minimum amount of time an algorithm could take to complete. And the average case analysis involves finding the expected amount of time an algorithm will take to complete based on the distribution of inputs. Let's take quicksort as an example. In worst case, quicksort has the time complexity of O n to the power 2, which occurs when the pivot is always the largest or smallest element in an array. In best case, quicksort has the time complexity of O n log n times, which occurs when the pivot is always median element in the array. In the array case, in the average case, quicksort has time complexity of O n log n as well, assuming random distribution of inputs. Common algorithms. Some common algorithms include linear search, binary search, bubble sort, and quicksort. Linear search has time complexity of O to the O into n, while the binary search has the time complexity of O log n. Bubble sort also has a complexity of O n to the power 2, while the quicksort has the complexity of O n log n. By analyzing the time complexity of these algorithms, we can determine which ones are more efficient for different types of datasets. It's important to note that the time complexity of an algorithm is not the only factor to consider when choosing which algorithm to use. Other factors such as space complexity and ease of implementation should also be taken into account. However, understanding the time complexity of an algorithm is a crucial step in optimizing code and improving performance. Coming on to space complexity. In algorithm analysis, space complexity refers to the amount of memory required by an algorithm to solve a problem. This is different from time complexity, which measures the amount of time it takes for an algorithm to solve a problem. For example, let's say we have two algorithms that solves the same problem. Algorithm A requires O(n) space complexity and O(n) to the power 2 time complexity is taken by B. And O(n) to the power 2 space complexity and O(n) time complexity, depending on the specific problem and constraints, one algorithm may be more efficient than other. Trade-offs. We design algorithms. There are often trade-offs between time and space complexity. Time complexity refers to the amount of time taken for an algorithm to complete its task, while space complexity refers to the amount of memory required to store data during the execution of an algorithm. For example, a sorting algorithm with a high time complexity may be faster at sorting large data sets, but requires more memory to do so. On other hand, a sorting algorithm with low time complexity may take longer to sort a data set, which is large in size, but use less memory. The choice of which algorithm to use depends on the specific needs of an application. Real world applications of algorithms. Algorithm analysis plays a crucial role in various fields, including computer science, engineering, businesses, etc. For instance, in computer science, algorithms are used to optimize search engines and image recognition softwares and natural language processing systems. Algorithm analysis helps developers to identify more efficient algorithms for their tasks, improving the performance of these systems. Similarly, engineers use algorithm analysis to design data optimize complex systems such as transportation, networks, power grids, manufacturing process by analyzing the time space complexities of different algorithms. Engineers can identify the most solutions to these problems, reducing costs of it and improving the efficiency. So, coming on to conclusion, in conclusion, we have learned about the importance of algorithm analysis in computer science and beyond. By analyzing the algorithms, we can determine their time and space complexities, which allows us to make informed decisions about algorithm designs and implementation. Overall, algorithm analysis is a crucial tool for anyone working with algorithms, whether in computer science, engineering, or business. By understanding the concepts we covered in this presentation, you will be better equipped to analyze and optimize the algorithms in your own work. So, this is a presentation. For today, we are signing off. Please do like, share.